thank you for having me, and thank you all for attending. What we'll be talking about today is exploring the network of things. The network of things is sort of a more formalized version of the Internet of Things. So we'll be talking about the Internet of Things, but we'll also be introducing this concept of the network of things. And it's from the National Institute of Science and Technology, and it's just an attempt, I guess, at trying to add some formalism around this thing called the Internet of Things. So we'll start with a brief introduction on the topic. We'll talk about some of the many definitions there are for the Internet of Things. After that, we'll introduce the concept of the network of things. Then we'll talk about some of the enabling technologies. What are the technologies that are enabling the Internet of Things now, and what do we see as the emerging technologies that are going to help bring the Internet of Things more into the mainstream? Give some examples of the Internet of Things and the network of things. So where are some places where this technology has been put into action and is making changes in the way people live? And talk about the future, what the challenges are, and what directions we see this taking. So a couple quotes up here. When wireless is perfectly applied, the whole Earth will be converted into a huge brain, which in fact it is, all things being particles of a real and rhythmic whole. And the instruments through which we shall be able to do this will be amazingly simple compared to our present telephone. So this was Nikola Tesla in 1926. Other quote that I thought was particularly pertinent: ubiquitous computing is roughly the opposite of virtual reality. So virtual reality, we put people sort of inside a world generated by the computer. We're moving into a more ubiquitous computing where the computer has to live out here in the world with people. So the network, the Internet of Things, is the network of physical devices. So things like homes and cars and appliances, things like your activity tracker. And so these devices, they're embedded with electronics, software, sensors, actuators, and they have connectivity which enables these objects to connect and exchange data. So Forrester predicts that this market will grow from 157 billion in 2016 to 457 billion in 2020. Bain predicts that the business-to-business segment of the Internet of Things is going to generate more than 300 billion annually by 2020. We expect to see over close to 50 billion connected things connected via the Internet by 2020. And the Internet of Things is an instantiation of the network of things. So IoT solutions, they require the Internet of Things involves the Internet, where a network of things could be a local area network. So same kinds of technology could be used without the Internet for specific closed-loop kind of applications, but still could be considered a network of things because a bunch of different devices are passing data and making decisions or inspiring decisions. So some of the definitions that I've found for the Internet of Things: defines the system of physical objects in the world that connect to the Internet via sensors. It's a network of smart objects. A huge number of devices are intelligently communicating in the presence of the Internet protocol. Doesn't require human beings to be operated, exists as components in places and on people and in the environment. IoT is the networking smart objects, in which smart objects have some constraints, limited bandwidth, etc. And the purpose is to achieve interoperability among the smart objects. IEEE communications, the Internet of Things, is a framework of all things that have a representation in the presence of the Internet in such a way that new applications and services enable the interaction in the physical and virtual world in a form of machine-to-machine communication. It is the interaction of everyday objects, computing devices through the Internet, enables sending and receiving of useful data. And all of these are decent definitions of the Internet of Things. So in summary, I guess it's a worldwide network where intelligent objects are interconnected and uniquely representable on the basis of communication-based protocols. So even more simply put, The Internet of Things includes services and networks and sensors. And it's services and networks and sensors that, through the Internet, communicate and pass data and enable decisions. So 4 key technology enablers. RFID technology to make it possible to tag things. Sensor technologies to make it possible to see things or to sense things. Smart technologies to actually think about things, apply some artificial intelligence, make some decisions. And then nanotechnologies for shrinking things. So these are the things that sort of brought the Internet of Things sort of out of the closet and more into the mainstream. And we'll talk a little bit more in a bit about some of the things that are currently emerging or maturing that are precursors of what the Internet of Things could be. So many consider this to be the 3rd generation of the World Wide Web. We started with browser-based Internet usage. We got into this social media Internet usage where people were connecting via the Internet. And now we're moving into this Internet of Things where people and things are connected via the Internet. So if we just think about at a conceptual level, what are the layers of the Internet of Things? So there is a perception layer, which collects information from the environment, from sensors, from temperature, atmospheric conditions, various devices and computers. It takes that information and it transforms it into a computer usable state. And the perception layer depends that each thing has a unique identification and that there is communication possible via short-range technologies between these things. So the network layer is really the brain. It is how data is secured and transmitted from the perception layer to the application layer. So information flows from the perception layer. It gets processed through the network layer, and then at the application level, that's where the actual services that are based on the needs of the particular use case and users. So this particular instantiation of an Internet of Things is intended to solve a particular problem, whether it is telling you how to get to your next meeting or telling your car to tell you where the closest place to plug it in is, things like that. Some consider that there's a 4th layer between the network and the application, which they refer to as the support layer, and it relies on cloud computing and fog computing. And I have several slides later on that talk specifically about why this support layer might be necessary and what we mean by fog computing. So I will get into that in a few minutes. So the network of things. Jeff Voss of the National Institute of Science and Technology, several years back, was troubled by the fact that there's really no formal analytic or even a descriptive set of building blocks that make it possible to compare different Internet of Things. So there's no real there's no standards. People are throwing things together and saying, this is my instance of the Internet of Things, and that's not a bad thing. But he felt, and NIST agreed with him, that it would make sense to put some sort of scientific and measurement basis around this notion of the Internet of Things into something a little bit more sensible, more easily defined, or you saw how many definitions there were for the Internet of Things. They're trying to sort of add some rigor and formality to the description of a system as a network of things. So they published this publication 800-183 called The Network of Things. And it's intended to offer sort of some foundational science and some underpinning for an Internet of Things based on the belief that it involves 4 things. It involves sensing, it involves computing,